All right, episode 10. Welcome to Defen. Ray McDermott in Belgium.
And this is Vijay Kiran in Holland or the Netherlands, depending on how you see it.
So how are you doing, Vijay?
No, I mean, there is a CGP Grey video explaining, what Holland is and what Netherlands is and all the crap. So, but technically, I'm in the Netherlands, but I'm still in Holland as well, because this is the part where I live in is actually part of the Holland, which was, I think, one of the provinces at some point.
Okay, I'm actually in Flanders.
Oh yeah,
which
in
is
Belgium.
the northern half of Belgium. So there's three parts of Belgium as well. Like there's Flanders, there's Wallonia, and then there's the Brussels region. Okay. So I'm actually very, very close to all three, but I'm in Flanders.
So is it the place where they speak Flemish?
They speak Flemish in Flanders, yeah. Okay. And they speak French in Wallonia.
Okay.
And they have different names for towns. Oh. If you're in Wallonia, then they call the Flemish towns something else to what the Flemish people call it.
Okay. Wow.
Yeah, it's really good. Yeah.
Interesting.
You have these road signs that say you're going to Antwerp, for instance.
Yeah.
But if you're French, Antwerp doesn't exist. If you're a Wallonian, if you're a Walloon, that doesn't exist.
Okay.
Only Anvers exists.
Wow. Okay.
So you have to go towards Anvers.
It is probably only the French people that actually translate the names of the places, because I remember when first time I came here and I said, okay, this is The Hague, and then for the French people it's La Haye or something. Like, right. What is La Haye? The Hague. Oh, okay. Why do you have to translate place names? Just leave them alone. You don't translate my name, They're like proper nouns. Stop translating shit. Anyway, we don't want to offend any French audience. French language is awesome. Bonjour.
C'est bon.
C'est bon, yeah. Bonjour.
Bonjour, mes amis.
My apologies to the French people. I didn't want to pick on them. Anyway, so let's get on to the show. This is a very exciting milestone for Defen.
Yes,
because this is our 10th episode. So when we started, I think like 5 months ago or so, we thought we were going to be just a pilot, and then we get cancelled, and everybody will be just writing,
just laughing at us.
Exactly. But it has been an amazing experience, and we hope to continue this. And the numbers were pretty awesome. There is a lot of feedback, plenty of good feedback from the community, and we are very excited to have a lot of guests over the period, and also we would like to have more guests over the period as well. So this is something that we are looking forward to.
And I think we want to try and get the focus a little bit more global, don't we? We've had Robert from South Africa. We've had a few of the guys from America on. We really haven't had, given the fact we're in Europe, we really haven't had enough Europeans on. So we're going to try and correct that over the coming months. Definitely, we'll have some people from the Euro closure that's coming up.
But, of course. So we're going to make sure that we're going to hit our diversity quota.
Yeah. Yes. We're going to hire local.
Then I'll start like this, and I'll keep speaking like this, like an Indian, That'll be amazing. I'll be just keeping doing the proper Indian accent.
I actually couldn't tell any difference, to be honest. I really couldn't. Do that again.
That's racist. I really
that's the opposite. That's not me being colourblind. That's even me being voice blind.
No, I think I need to talk like Apu from Simpsons. Thank you. Come again. Something like that.
Okay. Now I'm doing it. You're doing it now. Yeah. Okay. Oh,
anyway,
I apologise to my Indian friends now. Let's not insult the Indian. Oh fuck. Okay, we've got the first. But that's good.
I think we're very excited to have double-digit episode of the podcast, and we have been doing it like every 2 weeks consistently, and thanks to the community support and people listening in, and obviously we couldn't have done this without amazing guests showing up and teaching us a lot of stuff, and hopefully the people the folks who are listening to this, hopefully you're getting some value out of it. And we'll continue to do this as long as, possible. And we plan to bring in more guests in and talk to them. And so you'll get all the closure knowledge embedded across the world, channeled through this podcast to you guys.
It'll be always the latest, the greatest, the hottest vegetarian closure stuff you can possibly deal with.
Exactly.
So actually, the other thing we're doing is we're experimenting with going very long, aren't we? We've went kind of like for an hour, then we went for an hour and 5, an hour and 10, an hour and 15. Last time it was an hour and 30. Yes. We're going to go for we're going to pull an all-nighter one of these days. You know,
we'll pushing the boundaries.
If anyone notices.
Exactly. And then we'll know who are the hardcore fans of FM. There'll be just one person somewhere on the planet trying to figure out what the hell is this, and then continues. This is going to end, right? And then he'll be asking other people. This should end at some point. But yeah, it's been a very long episode, but I think it was very informative. The last one with Michael and Lucas, I mean, it was amazing.
It was really good. I mean, I think those guys really gave us some gold. I think you know it was. It's a great journey they're on as well. I mean, I think they're doing great stuff for the Clojure community. Obviously, big data is an awesome place that Clojure can really help with.
Yeah.
I'm really a big fan of their work. I think they're doing great stuff, and I'm really hoping that we can make more use of it in the future in a commercial setting as well.
Yeah. But if you're
kudos to you, Lucas. Kudos to you, Michael. If you're listening, thank you very much.
Yeah, thank you very much. So we'll be bringing in a lot of new guests, and of course we'll continue to do this. And before we get on to the show's main topic, first of all, let's have some couple of interesting things. So the news and events. So there is a Clojure Tray happened, and in Tampere, I think in Finland, and all the talks are on YouTube. Obviously, they've been tweeted and everywhere. We'll add some links to the to our notes, show notes, so you can check that out. And Euroclojure is going to happen in October, obviously. We've been talking about it a long time, and Ray and I are planning for something interesting to do at Euroclojure. We are working on the details, but both of us will be there, and maybe there will be some sort of a recording of the speakers or people who are in the community. We'd like to do a couple of interviews with them. That is certainly on the board. And we'd also like to give away some swag, goodies during the Euroclojure. So once we have more details, we'll tweet about it. We'll tell the community, and we'll announce it in the podcast as well. So those are the news and events. And because this is, we thought, hey, we keep introducing guests all the time, and I see a lot of people actually are very excited by having a guest on the show. So we thought, hey, we'll have a special guest. But this time, for your impure amusement, we'd like to introduce you to Def Ray. Hello.
Hi, this is Def Ray, yes, impure amusement. I'm a self-styled Clojure comedian, the niches of all niches. If you're looking at niches, then come no further than the ultimate niche of Clojure comedy. It all goes back, of course, to Lisp. And do you know the origins of Lisp, actually? There was a graduate student of McCarthy, and he had a speech impediment. And it was a bit of a joke amongst the research community that Lisp processing, it's called Lisp processing. And this guy was always having to say it again and again, and it was embarrassing. And McCarthy thought, I will make a great joke out of this. So instead of calling it Lisp processing, he just called it Lisp.
So it's basically a joke. That's a nice way to offend like a bazillion people.
That's how it started. But actually, all the fun in Lisp actually was the beginning of Lisp was defun. It was defun. But the problem with defun is that actually you literally remove all of the fun. Defun. You take all the fun out of Lisp. It should be defun. That's what it should be. If you're talking to the kids these days, you want to have defun. Start with defun. Now, with Clojure, it went one better, and they literally removed fun, and it is said DEFN. And this particular podcast shows that all the fun has been removed from Clojure. So, luckily, we have macros. So I decided to inject all the fun back with a macro called def joke. Okay, and def joke takes two parameters. It's a setup and a punchline. Okay, and def joke, it's pretty awesome. But the first implementation of def joke, I'm afraid, was a bit of a failure because it had absolutely no side effects. so I remade def joke with def joke bang. Okay, because then inside of the body of def joke, you have to test for laughter. And if laughter is present, then esteem is increased as a side effect. So with that macro in place, we're now able to perform high order jokes. Okay, high order jokes, DJ. High order jokes is where you get a joke and then you take back a joke. That's the high order joke. And the best example of a high order joke is the comedic heckle. So VJ, give it your best shot.
So I need to tell a joke or something, or
No, you need to make a joke about my jokes, about how bad I am. That's what a heckle is. Fuck's sake. I'll cut this bit.
God damn it!
I'm gonna harass this bit, for God's sake.
Okay, you want to be harassed? Fuck, I'm not used to harassing white people, man.
Okay, we'll take that one. Oh, God, okay. So, yeah, I'm going to outsource it to you, alright? Just carry it like that. So, you guys are used to that.
This
Alright, forget it. Right, one final bit, okay?
Yeah.
So the next joke about, that I've created with Def Joke is it's actually about the way our industry works. It's about how everything in this, there's like this whole business about algorithms where you want to set up random stuff, the one-armed bandits. They have all these bandit algorithms through Netflix, etc. And what is the interesting thing about one-armed bandits is they produce random results. And in general, that's how people, and every bit of IT is basically working on a one-armed bandit principle. And I'm going to give you some examples of that. First example is business asks IT to do something. It's a total fucking one-armed bandit. We haven't got a clue what they want. They haven't got a clue what they're asking for. They might ask for something where they get all sevens. We can do it in 5 minutes. Normally, it's not like that. It's going to take a week. Why? Don't worry. It's a one-armed bandit of fun. That's what you get. Then we get the job and finally make a start. Okay, right, IT. What are we going to use? Oh, we're going to use a bunch of web frameworks. Which one are we going to use? I don't know. One-armed bandit. Bam. Web frameworks. They're in JavaScript. Awesome. Yeah. How is JavaScript going to work today? I don't fucking know. One-armed bandit. Boom! Right. Programmer options to compile to JS. Which one are we going to use? I don't know. One-armed bandit. JavaScript, looking at the browser. Well, hello Tom, what are we going to do today? How are we going to work on CSS today? One-armed bandit. Everything's good. Right, JavaScript view of V8. How's V8 going to work today? I've got no idea. One-armed bandit. JavaScript view of ECMAScript. Which bit of ECMAScript is covered in any of the browsers, the V8s, the languages, the bits of HUD? I don't know. One-armed bandit. Java compiler looking at C libraries. How much memory is going to leak today? I don't fucking know. One-armed bandit. C library is looking at hardware. Hardware! Hi! How are you going to do? Are you going to destroy yourself? Are you going to have interrupts? I don't know. So one-armed bandit. It's one-armed bandit all the way down. Defeated by the audience. Thank you very much.
That was our our comedic interlude with Def Ray. I think this is like I remember the show where on comedy. Sorry, what was that again? Cartoon Network some time ago. That's called Sheep in the Big City. And then in that one, after every show, at the end of the show, there is something called ranting Swede. So it's basically a guy coming onto the stage and ranting about shit for like 2 minutes continuously. They're like meatballs. They're meat, but they're not balls. They don't bounce. So why they're called balls? So I'm getting pissed off with this stuff. So like we should have Def Ray interlude every now and then. Like ranting.
Let's try and bring him back if we can.
Yeah.
I'm not sure he is, but seems quite like he's got his head screwed on a little bit.
Yeah. But we are very tightly run show, so we might need to give him a couple of parentheses every now and then. Not real money or something. Or maybe closure coins. But we'll see.
Give him a closure coin.
We'll start building closure coins.
Let's keep his jokes in parentheses, though. That's for sure.
Yeah. Okay, let's get on to the main discussion. Today we're going to talk about specs. We have been contemplating what to call the show, because we were thinking Spec.ial, as in spec is already there in special, and so this is a special show about spec, and then there was something like spectacularly awesome show or whatever. But we'll let you guys decide, what kind of show this is. Anyway, so the point is we're going to talk about spec. So first of all, what exactly is a spec? So we have seen the announcement from Rich Hickey a couple of months ago, if I remember correctly, somewhere in April, I suppose, as the first incarnation of spec was unleashed onto this world by His Holiness Rich Hickey onto the world. And he said, okay, this is how thou shalt not write static typing shit on your closure, but thou shalt write spec or something. So the idea behind spec is fairly simple as far as I understand, because we have been trying, Clojure is a dynamic language, right? So we have been trying to come to terms with how to write correct programs, or get some sort of a guarantee on, hey, my program is not going to blow up at runtime. This is the standard argument that static typing people have, and again is dynamic programming usually. So one way to do that is essentially writing a lot of tests and then checking everything, but there is no easy way to communicate to the other programmers what your function means actually. So type system does that to a certain extent, because when you're writing in a statically typed language, for example, you can say, hey, my function takes an integer, and a string for some reason. So number of times you want to repeat and number of lines you want to print and the string itself, something like that. So there is a function. So that has been fairly useful, because you can when at the call site, you can check what kind of parameters your function is going to take, and you can guarantee that you can never pass it a double, and a character, right? So that's the basic idea behind type checking. That gives you some sort of a guarantee. Now, on the Clojure side of it, because we don't have any static typing involved, there were a lot of tools like Schema, for example, that was very popular from now called Plumatic Schema, if I remember correctly.
Plumatic, yeah, that's right. Originally the Prismatic guys.
Exactly. So Prismatic guys were making it. But that was very nice, because you could define the shape of the data, because usually you're interested in the shape of the data, not just the types themselves and how they relate to each other. And also you want to have a bit more control on specifying, okay, this map must have these keys. So you're talking about the content, not just about the type. So that was very well. I'm just giving I think we're just giving a bird's eye view of what it is. I'm pretty sure long-time Clojure users.
Remember, we also had the Clojure core typed as well,
yeah,
from Ambrose. So it's a whole gradual typing thing, isn't it?
Yeah.
That's what we're it's kind of struggling with, this notion that we don't want types everywhere, because they're not useful everywhere on the trivial things.
Yeah.
But they are useful on some things, like you say, when you want to communicate some interface, or where things are getting a bit sticky or a bit hairy, or you need to do some proper kind of thinking or testing about those functions.
Exactly. So this is more like a surface typing, right? I mean, the outside of the program should be able to tell you, hey, you cannot pass these things, you cannot do these things.
Well, actually, I think that's one use of it, isn't it? But I think we'll talk a bit later about the fact that Spec offers a lot more than that as well.
Yeah.
So it does give that kind of thing from a kind of contract perspective, let's say. That's what types offer. That's what you're talking about, isn't it?
Yeah, exactly.
It's the kind of like some contract to the caller.
Yeah. So the contracts are, I don't know if anyone who is listening to the show is familiar with Racket. So Racket has this contract system that's basically making sure that your program has some sort of they have different types of contracts. They have, I think, for functions and for data structures, and they have creating a combinators for the contracts. In my understanding, I think the Clojure spec is more or less similar to the contracts in Racket, because they try to like one part of the program not knowing what the other part is doing, so you're preventing those kind of issues. So usage of a function versus definition of a function, or making sure that you know the types, making sure that you know the data, and raising appropriate error messages, saying, hey, I expected this to be a Boolean and you gave me a keyword or something. So that kind of things. So that works pretty well in Racket. In my understanding, maybe, obviously the best way to get information from people is being wrong on the internet, right? Just tell somebody something wrong and then they'll make sure that you get the right answer. So that's what my opinion is. If it is wrong, please, just heckle us on Reddit or something. Anyway, so
I think there's more. I think because Racket is based upon a lot of more, because obviously Racket and contracts, there's a lot more stuff underneath it, isn't it? They've got a more. Their type thing has been going for a bit longer, and they've got these.
Yeah, they have typed Racket
kind of hygienic macros and all this kind of shit. So
yeah.
Their contracts, I think, are more complicated than Spec is. But on the other hand, Spec is actually offering more affordances than contracts as well.
Yeah, that's true.
With the testing stuff.
Yeah.
But yeah, I mean you're right. That's what people want, isn't it? They want this kind of, at the surface, they want this contract.
Yeah, and also the
Spec
guarantee.
offers some of that.
And also the guarantee and the communication, right? I mean, the communication between one programmer to the other. Because type systems are essentially, of course, they're communicating with the programmer. So when you write code, when I read that code, I know what the type is and what it is doing. But it doesn't give me enough of constraints that you're going to put around it. Because it's only talking about integer, or number, and string. So it's not talking about what is its name, what is its purpose, and what kind of properties that particular element can have. So I need to specify, because I'm calculating, I think before the show we were talking about an example where there is a weight of the car and mileage of the car, right? And I want to make sure that the weight is less than the mileage, otherwise I don't think there is any car in the world that just has more mileage than its weight in the absolute numbers.
Well, actually, mileage is 0 at the beginning. So, sorry. Your test is a fuck up from the beginning.
It's probably the other way around. So
no, it's just... It's a terrible example.
See, that's
you're wrong on the internet.
Exactly. That's the advantage of being wrong on the internet.
I'd like you to write that spec for next week.
So, weight.
I've done work for a car company, Yes. Let's not spend time on it, VJ. Though. Come on.
Okay. So enough.
We've got other examples here. Your general point is well taken.
Yeah. Enough about car analogies, because those suck. We all know that. Okay. Oh, man. So
what were we talking about there? With oh my God, the thing about the workflow. That's what I was going to say to you. Yeah. Because the biggest problem, I think. Because we're talking about types and contracts and all this other stuff, and that's all fine. But what we want to avoid with what we like about Clojure is all this REPL stuff, all this stuff. We can be free and we can just have the data, and we can be very data centric and very data oriented, and we can just play with our own maps and evolve it at the REPL and build it up. And that's really what we win with Clojure, isn't it? And we don't want this spec stuff to get in the way of that. Whereas types do, don't they? That's the biggest thing. That I think we want that balance, don't we? We want the balance between kind of like the freedom and the creativity of a language where types are not imposed upon us, but we want the kind of affordances of types where we need them.
Yeah, that's true, because it's a different kind of thinking. So once you get used to the dynamic thinking, then you're not essentially thinking in terms of types, but you're thinking in terms of pure data. But the point is, how do you then guarantee that, hey, my program is correct enough? So there are multiple ways, right? I mean, one of the ways that the type system guys come up with is, if you have the right types, then essentially you have the proof that your program is correct, because the compiler is validating it. But still the burden of proof, as in you need to define what a correct program is in types. So you need to specify. But compiler is going to help you. That's pretty good with the statically typed languages. But there are some situations where you can't actually prove it. I mean, there is no formal proof. Of course, I can spend more time, but there are some the relation between inputs or between inputs or outputs and inputs. how do you express in a type system, or how do you express it as a proof? So that makes it's even more complicated. So that's what the specs are going to be helpful, because it is still dynamic language. And
So what about higher kind of types and things like that in Haskell?
well,
Because in theory you can have a kind of what should we say, almost like an algorithm or a kind of set of semantics around the types with higher kind of types.
yeah, that's true. But
To be honest, I'm not an expert about it, and
well,
I
we know
haven't got that far.
we know we both are not experts, so we can just exchange our
Well, I've heard people talk about it on the internet, so therefore I'm a kind of expert, I mean, give me a break here, come on.
Are you a regular listener of Defen podcast? Yeah, I mean,
But anyway, but yeah, all I mean is that that may be possible. I guess the downside about that is you have to spend a lot of time pleasing the compiler, and that could be something that you're happy to do. I mean, if I know these guys who do this type checking stuff are really into it, and they believe that they can get more correct stuff through Haskell and F# and all these other things, Whereas I personally see it as a burden. So I think it's just a different style, isn't it? You know?
Yeah.
But we do end up wanting the same kind of thing. We want the best of both worlds, don't we?
Exactly. I mean, the idea is that our goal is the same, right? Our goal is to make sure that we write correct programs, or we need the tools to write correct programs. So there are multiple ways of achieving it, and type systems are one of those. So the argument here for specs is that specs are more specs remove a couple of limitations, or don't have the limitations that types have. That, for example, what we can do or what we can prove. So that the advantage is that you can communicate better with other programmers. You can communicate better with other tools, for example. You can communicate better with during compilation time and everything. And also, most of the time we're not just interested in the type itself. We are interested in the value, right? I mean, we can say, hey, it is an integer, and we can keep saying that. But what we're interested in is, hey, whether, my apologies, I'm going back to the car again, a mileage.
You're putting your hand in the fire again.
So if you say mileage, I mean, you can't fucking have mileage like 2,000 kilometers or something. That's
of course you can. Why not?
On a full tank. Mileage is basically per 100 liters or something, right? Or
okay. So now you're talking about fuel efficiency. I thought you meant like the number of miles that you've covered.
No. Oh God. Okay. See, that is the conflict.
Semantics. See, semantics.
Yeah, that's true. See, that's so we can keep saying it is double, but the mileage means something different to you than to me.
Yeah, we've just ambiguated it now. That's good.
Exactly. That's where the spec is going to help, because I'm going to write a spec that says, hey, this is what mileage means, and this is what the mileage property is. And then when you're reviewing my code, you can say, what the fuck, mileage is kilometers. Why is it like this? So that
why is it kilometers per liter?
Exactly. Yeah. So it makes more sense there. The whole specs idea. But now the most interesting part with specs, at least that it has been in Clojure, we keep saying everything should be a library, right? But in the case of specs, these are put into core. So why not a library? I mean, why specs are special, like special forms? So this is something fairly. I think you were explaining that Richiki was explaining why these things are part of the core, right?
Yeah, I think his argument was that even though it's not a language change, he wanted to make sure that it was sort of universal for all Clojure programmers to have this set of tools available to them. And that makes a lot of sense because, like you said just a moment ago there about communicating, if everyone has the same kind of tools, then it makes communication between developers and between teams and between companies or whatever, much more straightforward if they're all operating on the same tool set, because the situation we were in before was pretty ad hoc, where we had schema and core typed and check test and other, it was all kind of excuse me, it was all a little bit ad hoc, it was a little bit bric-a-brac. So one team could use one standard. It's still possible, of course. You can still use different standards.
Yeah.
But the defaults, and I think that's what I like about this approach, is that the default now becomes a pretty good default, a pretty good set of choices. Whereas, and you don't have to look beyond the core environment to get a very good, very powerful tool.
Yeah. So I think it makes sense that it is part of the core, because then you have some sort of a uniformity when people adopt this.
Yeah.
Then you have a uniform way of communicating it, because as we'll probably explore later in terms of the error messages, in terms of the effect on the ecosystem, it makes sense that everybody uses some well thought out system, right? So
yeah.
Otherwise, look at schema, for example. There are some libraries which adopt schema, which is pretty good, and then some libraries which don't, so because that's not the default thing available in the language that you can just pick it up. So that's why I think it makes more sense to make it part of this one. And also, I think that is also the reason. I don't know. Maybe we should ask Alex Miller or Richiki that there are a lot of alphas. They're getting a lot of feedback from the community. Like, okay, how is it gonna pan out? So
I think we're alpha 12 now, aren't we? Something like that.
Yeah.
So it's definitely
unusual.
I mean, we see it from the mailing list.
Yeah,
that there's
exactly.
a lot of there's certainly a lot of heat. There's a little bit of light, I think.
Yeah. But these kind of changes, I mean, these are fundamental and part of the core, and that I think it should be part of the core, not just a library. Because if it is just a library, then you have this. Of course, it is still optional, right? I mean, you don't need to write specs. You don't have
exactly.
to. You don't have to.
Yeah.
So you still have an advantage of writing it, because that helps you with, hey, now I've written a program. Now I want to guarantee whether this program is doing what I want it to do, and I want to communicate my intent. So which tool I would reach for. So this is something that I think is very interesting. Yeah.
Yeah. I think the other thing as well is that if you're building, tools or whatever, or if you're building libraries, then to start thinking, okay, well, I know schema seems to be very popular, so I'll invest my time there.
Yeah.
And I'm sure some people have done that.
Yeah.
And now they're kind of like sad because it's kind of going to become a bit less popular.
Yeah.
Whereas with this thing, if you put it in the core, and we know that Rich and the rest of the gang are behind it in the core team,
Yeah.
then the tool vendors and the library guys, and ourselves, of course, we can feel a bit more comfortable that the investment we make in this spec will have a long-term return on investment. And I think that is also a reason to put it in the 1.9.
Yeah, that's true. I think it's one of those fundamental, to use a cliche in a word, like a game changers. This is the tool that's part of the core, and this is something that you can reach out for, and they're expressive. Now you can. So what can you do with a spec? So you can.
Just one final point actually was the obvious library stroke user of spec is going to be ClojureScript. That was something which wasn't actually unified beforehand, and I saw David Nolan's talk at Clojure Tray we mentioned earlier on. And that's one of the things he mentioned in that talk, is that parity with Clojure is a very important thing, and it's the big work that they're doing now in ClojureScript is to keep parity with the alphas. So they're a little bit behind, but they're only like one or maybe it's two alphas at the most behind. So this will also be very nice that you'll be able to translate the specs or use the power of specs in ClojureScript as well as in Clojure proper.
Yeah.
Sorry. Yeah.
So what can you exactly do with it? So you can specify the. It's essentially adding some sort of a type I don't want to call it type specification, but a specification for a given data structure. So it could be for a function, it could be for a data structure, it could be even for a macro, for example. So this has been one of the interesting things with macro, is that you have this runtime and then you have this compile time, and you can get errors in a pretty strange places that you can't debug properly. So the specs helps you to identify, okay, where is my error and what is happening with that one. So there are lots of combinators available in specs. So you can say, okay, this has to conform to this particular predicate, essentially. So you can say all the parameters should be like this. And I think Stuart Holloway has an amazing series on YouTube explaining the screencast, explaining all these things. So I just don't want to. Yeah, there is no point in me talking about it. It's if it is coming from the source.
We should make a link.
Yeah.
We should make a link to those.
Exactly.
To those.
So I would really recommend that those are bite-sized. I mean, smaller, 15 minutes screencast explaining what is the leverage that you get by using specs, and what are the tools that you get, and how can you practically use specs to improve your programs. Now, the other so how do you check these things? So you have this the conformance testing and the validity of your code. Now, once you run the specs and quote unquote, or run the validation on it, you get all the results or the errors, but you get it in a form of a data structure, right? I mean, you get it as a map. This has been.
Well, yeah, I think you can have it as both, can't you?
Yeah.
You can come back just as a string, or you can have it as data.
Yeah. You can ask as a string, but I think this is a. I'm still making up my understanding of, trying to get in terms with having it as a map versus just putting it as a proper error message. It's still seems like a strange or a difficult choice, because if it just prints out a huge map with all the crappy things in it, I need to dig through. It is essentially like, well, I don't want to compare it to a stack trace, but you know what I mean, right? I see the huge map detail, and I want to get into this stuff.
Almost worse than a stack trace in some ways, because there's order in stack traces.
Yeah, exactly.
So it's guaranteed.
Yeah.
But I think we've seen some stuff on the mailing list, like you say, about
the cursive guys.
errors getting worse, and and we saw some discussion that everyone has to learn how to read specs. It's like, for Christ's sake, I thought it's meant to be optional. So if the core language is going to emit errors as spec failures, well, Jesus Christ, it's not very friendly. I mean, the whole point about this thing was to try and make it a bit more friendly for beginners and to help it to spot errors and things like that. So I really hope, and we can ask Alec about that. Oops, surprise guest, spoiled it. Hopefully we're going to have him on the show pretty soon. And God damn it,
we hope so.
We better come on now, and we can ask him a bit about that, because I think the opportunity is definitely there to improve matters.
Yeah.
So. Hopefully that's taken. I think the map thing is quite interesting from a tool vendor's perspective.
Yeah,
I think you were saying earlier about that there was some concept of not wanting to vary it too much.
Yeah, exactly. Because the idea is that if the results of a spec are shown as a map, then if you leave the tool vendors like the IDEs or Emacs or anybody to decide how they are rendered, how they are.
I think vaguely they do count as tool vendors. I know it's. I don't of course, really agree, but
in my mind, vendor is a bit more derogatory. I mean, people are doing amazing contributions to these are all open source stuff, and they're giving stuff away for free. So they're doing it for love, not to sell shit. So anyway, but the problem is that.
Aren't they getting karma? Isn't that their thing?
Yeah, of course they are.
The universe is loving them.
Exactly. There is some universe juice flowing into them.
Anyway, back to sorry.
Yeah.
Yes.
So the fundamental issue there is that it depends on how the tool interprets the map of results. So this is one of the contention point, because we just discussed mileage, right? It means different thing to you. It means different thing to me.
Well, you're wrong. Yeah.
Well, I don't think 2 billion Indians would say that. Because we have advertisements saying mileage, amazing mileage.
No, we're both wrong and we're both right. And that's the fun thing about it,
That the contextuality matters, right? I mean,
exactly. So, and that's your point about the error messages. Yeah,
exactly. If cursive is going to interpret or show these results in a different way than Emacs does, or VI does, or Nightshade does.
It'll probably do it in a better way, I think.
Yeah. Not better than Emacs though. But okay, I understand.
It will have more colors.
I understand you want to get a free license from Colin. but
I'm happy to give him my money. It's okay. Yeah.
But that is a fundamental contention point here. But in my opinion, I still think when you're running it without any tools or something, it should still be friendly. I mean, it is user experience, right? I mean, you can't ignore it. So
Yeah, that's right. Yeah, yeah. There should be a. I agree with you. I mean, there should be a decent universal sort of baseline of at least okay error messages.
exactly, because think about, because we're talking about specs, and you can test them during compile time, and you can also use it at the runtime. That means at runtime, I'll end up this shit in the log. So there,
Yeah.
I see completely different picture. Well, all the Clojure programmers are smart; they can figure out shit. But you want to reduce these brain cycles people spend on understanding the error messages, because this has been a big talking point about Clojure since the beginning. Clojure error
Yeah.
messages suck, so there has been multiple tools that have been built around it. So anyway,
I think there are actually it's interesting, isn't it? Because I think there are two parts to this. I think one part is the kind of like the forming of the error messages.
Yeah.
Because I think that I think the engineering team at Cognitech, they're struggling to have to find a way to present good error messages.
Yeah.
I think there are examples out in the wild, but I
Yeah.
think for whatever reason, maybe it's just engineering budget or whatever.
yeah,
They're really, I think they still haven't found a really nice way to go Elm on this shit. As they
yeah,
say.
exactly. I mean,
You know?
the Elm guys are doing
Um,
pretty great, by the way, right? I mean, if you see their error messages, they're, well, I haven't used it, so this is still the demo effect, probably. You just see some tweets every now and then you see, wow, that's amazing. It can just pinpoint the information. But I think Spec has the same potential.
Sorry, please
Sorry.
carry on.
Yeah. So specs have the potential, I mean, to be like Elm error messages, right? But it is not the default. That's the problem.
I think part of the problem, I mean, you have to remember also what Elm is. Elm is a typed language.
Yeah.
I mean, and that, so in some respects, it's fed more data
Yeah.
than the Clojure
Yeah, specs
equivalent
yeah.
is.
Yeah.
So but they definitely do some nice things, and they do. Other guys like Colin and like Bruce Hammond and Colin Fleming, those guys in their respective tools
Yeah.
are trying their best to find nice ways of expressing configuration errors or other kinds of errors. And I mean, my point is that for whatever reason, those guys are finding it difficult to. They've got the data, but they're finding it difficult to express
Yeah.
that message in a kind of human way, and that's partly because of the semantics of English or the semantics of the error or
Yeah.
whatever. And I think that's a hard problem, to be honest.
That's
And
true.
good. I wish them good luck with it.
Yeah.
Please make it happen.
Yeah.
But I don't exactly know how it's going to work. We've got some examples out in the wild, so work it out.
Yeah. Yeah.
It's definitely not a student exercise. I mean, I know they've got some serious engineering brains on this thing, so it's definitely not an easy problem. But what I think is the other part of this error messaging thing, which was a problem for Clojure, was the fact that because it's a dynamic language now, it's macro stuff, transforming macro A to form, from the macro outer form to the inner form to the as you keep on recursively expanding the macros, and then you get an error halfway through, then it sort of bonks, and you kind of lose the context. And now in theory, this should help there. In theory, the transformation of macros should help. Now again, I want to separate that out from the kind of forming of the error messages, but the pinpointing of where the error occurred, at least, should be done better. Because that's one of the biggest problems I think we've had in Clojure from day one is error messages are shit, that's for sure. I mean, I'm not going to pull any punches on that. They're often really terrible. But the thing, and what you end up doing is just sort of saying, oh, what did I do last? I'll undo that, and oh, what's the difference? Oh, I see. It's not always that obvious even, but what I was going to say was the bit that's horrible is the bit where you suddenly get this error message and you just don't know what it's telling you. You've got no clue, and it's got tribal knowledge basically on the user group to say, oh, I think it's probably that. Have you done this? Have you done that? And it's all just tribal, the knowledge there. And we want to get rid of that tribal knowledge crap. The compiler should know where the fuck the thing went wrong. And I get why it's hard, but I think this spec thing should help. And I've got high hopes,
Fingers crossed. We'll see how it pans out. But I mean, I think that there is a lot of community feedback coming in, and I see a lot of discussions on the mailing list, and hopefully we'll get to a place where specs are going to be a nice default thing that we can work on. So the runtime checking, obviously you can use specs to check during runtime as well, because you can use the provided functions like valid or confirm, for example. You can even do that during runtime. So you can say, hey, this is the data that I got. Does it conform to the spec that I have? Now I can take a decision or throw an error message or something. So specs are there during compile time and during runtime as well. So that is really helpful. And the other advantage is that
by the way, that's optional as well, isn't it? You don't have to do that.
Yes, exactly.
You can choose only to conform.
Yeah. So
and just use them as a sort of documentation.
Exactly. Yes. Yeah. You don't need to do. There is no have to at any point. So it's all optional. So the tools are available. If you want to use it, you can use it. And now because we are specifying the behavior of the functions or the properties of the functions. The one thing that's really exciting about specs, for me at least, is that you get automatic generative testing, automatic property based testing.
Yeah,
that is amazing.
That is massive. Yeah, massive.
That's a spectacular advantage that you get, because you don't need to write tests separately, and then you just generate them. Yeah.
Spectacular.
Yeah, spectacular.
You've done it. Yeah.
I think I should just name it spectacular.
They should really. Yeah.
Yeah.
Okay. So anyway, I agree with you. I mean, because. That's also I saw Stuart Holloway's video about that, about how to leverage these testing things.
Yeah.
And there's some really nice use cases there as well about how you can modify the inputs and the functions and the properties to tweak the generative testing models so that they give you the right type of data, the right type of testing. So you can take all the defaults, but you can also tweak it to say, okay, well, this give me a lot of non-zero values,
exactly.
For instance.
So you can write your own generators. Yeah. I think there are a couple of very nice talks on Clojure TV. For example, on Euro Clojure, there is a talk about generative testing. In a lot of places. I mean, the central idea being that you don't write tests to check the values, but you write tests as properties that your code should conform to. So
I think that the fundamental conceit behind some of these things is that unit tests are laborious and boring, and all they're often doing is kind of badly essentially speccing out the behavior of a function. And I remember, I know for a fact there are people at work this very day, well, not this day, it's a Sunday, hopefully they're off, but there are people at work on the open source, I'm sure, writing tests,
you
let me do my
outsource to, and then
writing tests. What the fuck are you writing all these tests for? You're just doing what the machine could do far better, and they don't get tired. It's like the sort of Terminator argument. It doesn't get tired. It never gives up.
And also, it's better at giving you the heuristic-based estimation when your program is gonna fail. So that makes more sense. Make the computer do the grunt work. You don't have to think about, okay, how many possible edge cases are there, and how many unit tests do I need to write. But again, the fundamental advantage here is that because you're using specs, they are pretty much what you're specifying the properties of a given function. So that gives you this amazing leverage of generating tests or generative tests. So that is something that is pretty cool. So there are lots of information online. I think we can link to all of those things. A couple of things that before we wrap up,
just one small point on that is that I think there's a lot of I think what's interesting about this is back to this sort of not exactly anti-Java or anti-type checking people, but obviously generative testing it's good for those guys as well, because in the end it tests the heart of your function, not just the types that are being passed in. So anything that anything that promotes the ease of use of that thing, then then you're kind of winning, because if you're writing a typed system, then you have to write some properties separately from it.
Yeah.
This is where I think Rich calls it leverage or leverage. He calls it leverage, I call it leverage, but can still be friends. And so I mean, the basic idea is that you make some investment there and you get a lot back, and you get a lot of rewards for doing one thing, whereas in the typed system you still have to write your unit tests, or you have to write this other thing, this property-based testing thing. So if you're a Haskell programmer, you have to use quick check. If you're a Java, all these checks. Well, if you're a Clojure programmer, guess what? You can write your things. You get all these advantages, and the test comes for free. Which is superb. Yeah.
But we still need to see what is the effect on the ecosystem once specs reach the release mode. We're really curious. How the tools or IDEs are going to pick it up, and how many because there going back to the community feedback, because the specs are now essentially making some of the Clojure code backward incompatible. So that is something that for example, the require in the namespace thing. There is huge there is some discussion on the mailing list about it. Essentially making, because people were using the
symbol.
The symbol instead of using the symbol, directly calling require in the namespace, and now it is now enforced by spec, and it is raising an error. And
it should be a keyword, not a symbol.
Exactly. So that is the kind of things that we might face, and I know Alex Miller has been opening some nice pull request for the program for the open source software, where you need to fix the code base, but there seems to be at least some sort of a common understanding in the community that, hey, spec is going to help us, so we should adopt it and then use it in one go. But this is the first time Clojure has ever broken the backward compatibility promise, right? I mean, there wasn't much issue in the past with all these releases from all the way from 1.0. So
I think it's interesting, isn't it? Because there's a sort of debate about whether that's really a backward compatibility issue,
that's
or
true.
whether it was just a kind of bug fix.
Because
but it's really an interesting problem, because on the one hand, I count it as a bug fix. So supporting broken behavior doesn't count as breaking backward compatibility. That's in many ways. I look at this thing with Sun or Oracle. I can't remember if it was Sun or Oracle, but they changed something to do with the way that. Oh no, it was when Oracle took over Sun. They changed the copyright string, I think, in the system properties. And they changed it to be Oracle and not Sun, so it was either one less word or something. It broke a lot of code, because people were, I'm looking for Sun microsystems. That's what I'm looking for. I'm looking for the Sun compiler. Well, I'm sorry, mate, but that was not a valid use of that thing. And they were moaning and bitching, oh, why do you change this? No, that wasn't the right thing to do. You happen to take advantage. No, in this case, it wasn't take advantage of. They just made. Often, most of these library guys will just made a mistake. It would have just went past the compiler.
Exactly.
The problem with it is that it's the ripple effect that's the problem, isn't it? Of course, in my opinion, it should be corrected. The interesting problem is the fact that if I change it, if it's like that, then okay, well, if I have to upgrade my version, then you have to upgrade your version.
That's
and
true.
That's the problem, I think, is that you're forcing people to do upgrades, and code that worked before now doesn't work anymore.
Well, at some point you need to move forward and then remove the wires and release wireless earpods. So at some point, I mean, there is this.
Well, I mean, this is a very benign change. I think this is.
It is.
This is not a radical change. This is a small wart that's being removed. That was essentially a bug.
That's true.
That allowed this behavior to go wrong. So I think removing that little wart is okay. I'm all for that.
Yeah. So you're gonna buy the AirPods or
the earbuds.
That was when I first saw the advertisement, I was like, God damn it, they're removing the wired things. But then I realized, I mean, after a couple of days, I was taking out all the fucking wires from my bag and they were entangled. I was like, fuck this thing. I'd rather lose my earpods than fighting with the shit wires tangling all the time.
Yeah. I'm wearing a pair of wired headphones now.
Yeah, of course. Me too.
But only for the sake of this podcast, actually, because I bought a pair of wireless ones.
Okay.
And I'm far happier with them.
Yeah.
The only reason I wear the wired ones now is just because I don't want to have the interference, and I don't want to experiment for this show.
Yeah.
But I will do that in the future. And honestly, I think wired is I hate wires.
Gone.
You know,
Yeah.
I hate wires. You have to have wires for some things, but I think they've done all right. We're off the topic by a fucking mile now, though.
Sorry.
You know? But
anyway.
I think it's fine. I think they're doing all right. They're actually building a bridge as well. They've got a little plug, so it's okay. Backward compatibility is retained.
Yeah.
So anyway, what I was going to say was so there's that small thing, yeah, and like you said, the better tooling. Hopefully, we'll see the error messages coming up and the other things. And one of the things that Rich was talking about as a goal for Spec actually was the versioning part, because one of the things that Elm does, and I don't know if you know this, but what Elm does is, let's say you make a change to some type or some function, it knows, it's aware of what the Semver spec is, what the Semver contract is, and if you make a change to your program, it will tell you whether to bump the patch version, the minor version, or the major version.
That's nice.
So it's really nice, yeah. And what he's saying is that's what Spec will allow us to do as well. It will allow us to understand whether we've actually made a change that breaks something in a more mathematical sense. So you know, if we're removing one thing from a set, then okay, it's fine. You know, we can do that.
Okay.
And I think that concept, it's not something which Spec delivers on now, or you know, whatever, but it's maybe something which maybe, as you could imagine, Boot or Leiningen or you know, Clojars, or there could be some tooling around that environment to say, oh, you know,
this version is providing
there's a plugin. Actually, it's not a plugin anymore for Leiningen called Pedantic. And that Pedantic plugin does certain things about the dependencies and that kind of stuff. You could imagine something maybe it's like that here, where you could say, okay, this version, I see the spec here is like that, and the spec. It's going to take a while to get everything spec'd up, I guess, to the point where that's useful. But I think there's more chance of that happening with Spec being in the core. Because I think Ambrose Bonner-Sargent always says, you know, oh, come on guys, do the core type.
For your libraries.
But, you know, I think people can't be asked. I mean, I'm sorry, but it's just not something... I wish him the best of luck. But I really... I think it's somewhat quixotic to think that everyone's going to do it when it's a non-default. It's not part of the normal thing. It's, you know, there's the only real benefit is for the greater good. The nice thing about Spec is that the actual library author gets some benefit. Well, you could argue that they get some benefit with core types as well, but you get a lot more benefits with using Spec.
That's true.
With all these kind of packages that come together. So I think that you'll see a lot bigger adoption of Spec than you have of these other platforms and these other toolkits. These other toolkits.
Anyway, I think that's pretty much it, I think.
Wow,
so I mean, of course, Spec is still evolving. There are a lot of alphas, and I'm pretty sure people are checking it out. And we'll post all the links that we know of, and we'll put the show notes on defen.audio as usual, and you will see our episode on SoundCloud and also on iTunes. And it would be very nice if you folks can give us some feedback, or at least rate it on iTunes and SoundCloud. Then we become even more popular, and then we get to have more guests on the show, and instead of us boring you all the time. So that's pretty much it from us, I think, and we'd like to give a quick end credits, Ray.
Just a final thank you to Pizzeri for the outro music. He does a good job every week. He's always there for us with his vegetarian intros and outros, the melon hamburger. And yeah, I think that's very good. Well, what can I say? Happy 10th episode, VJ.
Yeah, happy 10th episode to you as well.
Before we finish off, actually, I think it's quite fun because me and you met for, I don't know, half an hour at the Dutch Closure Days, and we've spent far more time doing this podcast than we've ever done in person or anything like that. We're going to be together for the first time again after that at the Euro Closure.
Yeah.
So it will actually be good to see you again.
Yeah.
And to hang out, it'll be really good.
Yeah.
And I've really enjoyed doing these shows. We've done the first 10.
Yeah.
It's been good fun. I think we can do another 10.
Of course. I mean, it's all your idea, obviously, and I'm really happy to be part of this one. And for the folks who are listening, I mean, there is tremendous amount of work Ray puts into this show. I just usually on the Sunday evening, I just show up and then plug in the mic and then start blabbering into the microphone, and then I just go to sleep. But
I cut most of it out, in fairness.
That's true. But yeah, I mean, this has been an incredible opportunity for us to every other weekend talking to you, and also having all these guests to learn from, and hopefully the people who are listening and they're getting some value out of it. And we'd love to hear from you, and we hope to take it to, I don't know, triple-digit episodes. Hopefully, we'll see.
Wow, that would be pretty phenomenal. All right, mate. See you next time, mate.
See you next time.
Yeah, bye.
Yep.